is network address translation layer 3 operating mode, or maybe it is working in a transparent mode, which is a layer 2 mode. If you are using VLANs, it will show you. If you are in an HA mode that is working in a cluster, either in a passive mode or in an active mode, it will also show you. Currently, as we can see, we are not participating in an HA cluster, so the HA mode is standalone. We can also see if we're using a hard disk or maybe we're using a flash disk. So the get system status will show you the most relevant information regarding your Fortigate. Another chapter in 2 minutes CLI, and in this part we will look at the execute log display. How can we show up the different logs categories in the command line? Coming up. Logs are critical to your network stability and your network security. Now, it's a good practice to keep logs for at least a week. You can look at the logs either through your Fortigate or through a Forti analyzer or even a syslog server. Now, in your logs, you have different categories, and we will look at them through the command line. So for that, we'll use the execute log filter category. Now, if you're not familiar with the different categories, just press enter, and there you will see the different categories. So let's just use category 1 for event logs. Now, after doing so, you will need to write down execute log display. And there we have it. Now, it shows up only the 10 last log events. If you want to watch the other 10, just press again and you will see the other 10 log events. Fortigate also shows you that you have 237 logs that are found and only 10 logs are returned. 6.4 is one of the latest releases of Fortinet, and they're doing a great job from release to release, adding new features. And up until now, there were dozens of videos all over describing the new features of 6.4. Well, I've decided to create one that will focus on the more friendly features of 6.4. So let's start. The first friendly feature, is the execute speed test that you can do on your WAN interface. To do so, you'll have to have the SD-WAN network monitor license. Once you have one, you can jump up to your WAN interface and execute a speed test. Now, when you do so, the results will be added to your estimated bandwidth, the estimated WAN bandwidth, but you will have to be connected to FortiGuard and to, I believe, Google's or AWS speed test servers. The second friendly feature is a fantastic one. I've been always asked when dealing with security profiles, which feature is supported either in flow-based inspection mode or in proxy-based inspection mode. And it seems that up until 6.4, you had to remember which feature is supported and where. So from now, you can actually create a new security profile. And if you wish to see which feature or which capability is supported under the proxy inspection mode, the only thing that you need to do is to click on the proxy based, and there you will see that you can only use content disarm and reconstruction under the proxy based mode. The same goes to web filter. Just click on the proxy based and you will see the features that are supported only on a proxy-based inspection mode. The next friendly feature is actually not a feature. It is a way of describing things much more clearly. So when you go to a network SD-WAN and you add up new interfaces to be part of the SD-WAN interface, and the next thing is to create an SLA, a performance SLA, where you configure the SLA server and the SLA target. The next thing is to go to SD-WAN rules. Now, in SD-WAN rules, at the end, you actually create your SD-WAN strategy. The SD-WAN strategy can be manual, best quality, maximize bandwidth, and lowest cost. I can tell you that every student asks me, what does it mean? What is best quality? What is maximized bandwidth? So finally, Fortinet actually describes each strategy and what it does. The next friendly feature is a cool feature, which is the IP address tooltip. Whenever you hover with your mouse over an IP address, it will show up more information on that IP address. So let's go to login report and application control, and let's see what happens when we hover towards that IP address. Well, we can see that the owner is Google. We can see the location, which is England. We can also see the latitude, longitude, and the running services. Let's go to another IP address, and that IP address also is owned by Google. Let's find an IP address which may not be owned by Google. All right, so we have an IP address that the owner is Amazon, and it seems as the local CDN here in Israel, Tel Aviv. Another friendly feature is the Add widget, which is now much more organized than it was before. You have dozens of widgets. Some of them are new. I believe that the IPsec and the SSL VPN widgets are new. And you have a bunch of Wi-Fi widgets that shows you the channel utilization of the access point, clients per access point, interfering access points, and so on. And the last friendly feature is the fact that you now don't have an IPv4 policy and an IPv6 policy. You only have a firewall policy. You can add up an IPv6 or an IPv4 address object to be added to the source and destination fields in your one policy. You're a small business, very small. 6 employees, 6 computers, 1 switch, 1 access point, an ISP router, 1 subnet, and a network attached storage that serves as a file server. That's right, no domain controller servers, no clustering, everything is flat and simple. But you still want to protect your network assets. You still want to be able to connect to your file servers from remote, give permissions to the management to specific domains, and you decided to buy a firewall, a small firewall, not too fancy. So here are the 7 things you must do in order to start and work with your firewall. All right, so the following are the basic steps that you as a small business will need to do once you get your FortiGate or any other firewall in your business. Now, the very first thing, remember, once you configure your firewall, you're the administrator of that firewall. You're the super admin. So you will need to hardening your admin account. You can use two-factor authentication. You can also use an email-based mean to get a token in your email. I have done a video on that before, and you can just click the link above and go straight to it. Another thing is trusted host. You will need to configure either 1, 2, or 3 IP addresses that the admin can actually connect from to the management interface of your Fortigate. So configure your office address, configure your home address. Don't let anyone get into your Fortigate from outside. The second thing that you can do is to segment your network. Now, even if you have only 6 or 10 employees, and 3 of them are in the marketing department, and 4 of them are doing sales, create a new interface. You have lots of switch ports on your Fortigate, and even if don't, you can create virtual LANs. So let's create an interface. Let's just name our interface sales. The role of that interface is local area network. Just assign specific subnet to that interface. This is a private IP address. Use for management HTTPS and SSH. HTTPS to get to that interface through the GUI, and SSH is through the command line, and just configure a DHCP server. Now, you probably have only about 5 to 6 employees, so don't use the full pool. You can use if in our case it's 10.0.9.2, so let's use it up until .10. Now you can do many other things. We will not get into it right now, but this is the basics of just creating a new interface, and be sure to connect those employees through their computers to that specific switch on your Fortigate, either using a switch or directly. All right, now once you've built the interfaces, you can actually start to configure some rules. Let's just use basic rules for now. We head over to policy and objects, IPv4 policies, create new, and let's just create a sales policy. Now, we're not limiting no one in our sales department. So the incoming interface is sale, the outgoing interface is our WAN interface, the interface that is connected to our ISP router. As for source, currently we will use all, but we will create a firewall address object very soon, and we can actually use it in our firewall policies. In terms of service, we will allow any service, any protocol to go through this firewall policy. We will enable NAT. We will not use currently our security profiles. We will do it soon. And we will log just about every session, not only security events session. All right. So that's our sales policy. Let's create a new policy. Let's name it marketing. And incoming interface is our marketing. Outgoing is our WAN. Source all. Destination all. Service all. Let's just enable logging for all sessions. All right, the next thing to do is to actually create a virtual LAN for our access point. Now, there are times when you need to create another broadcast domain which is on top of physical ports. So if your Fortigate has 8 ports, you can actually create on top of each port VLANs, virtual LANs that you can connect to that switch, and from there to outsource employees or other employees. So let's just use the sales port to create another interface, which is our VLAN interface. Let's name it outsource 2, and we will use a tagging of 300. Let's also use it here. And the interface, as we said, is the sales interface. Now let's configure an IP address as we do in just about every subnet, every LAN that we have. So we'll use the 192.168.2.1/24, and we'll use administrative access, HTTPS and SSH, and we will actually list the full pool in our DHCP server. We will not limit it to only specific number of IP addresses. Okay, now once we have that VLAN on our sales interface, that's VLAN 300, we need to create a policy that will allow any traffic that is coming from that VLAN to get out to the internet. So we will again create a new policy. Let's name it outsource to. The incoming interface is our VLAN, is outsource to, and the outgoing is our WAN interface. Now, anyone can connect to that VLAN, anyone can go anywhere, but in terms of service, we will not allow any service out there. We will use HTTPS, HTTP, all right, and DNS. All right, now let's just apply that, and now we have a new policy that allows anyone that connects to it to get out to the internet only using HTTP, HTTPS, and DNS. All right, now let's create a firewall address object. Why do we need a firewall address object? Well, sometimes we have different computers on our subnet that we want to limit or to grant access to specific services, and that's a good way to create a policy that is more granular. So to create a firewall address object, we'll go to policy and objects, addresses. Now let's decide that our firewall address object will be for the marketing division. That's at the 10.0.5.0 subnet. And we know that we have a user that has the 10.0.5.3 IP address, and we want to limit it from sending pings, sending ICMP protocol pings. So how do we do that? We go to the policy and objects, addresses, create new address. Now let's name our computer limited ICMP. That's a nice name. Let's use the IP range, and let's use the 10.0.5.2 up to 10.0.5.2, or we said that it will be .3. And the interface is the marketing interface. Okay, we can also use static route configuration if we want to use it in a specific static route, but we don't need it for now. Let's just apply that, and now let's create a new policy, and in our new policy we will name it no ICMP for that specific device. So the incoming interface is marketing, the outgoing is the WAN interface, and the source is the new limited ISP source that we have just created. Destination all, service ICMP, we want to limit it from sending ICMP ping. So we'll choose all ICMP and ping, and in the action we will choose deny. Okay, so now we have a policy that denies ICMP or denies pings from that specific users. Now for that policy to work, we need to actually move that policy before the marketing policy. So our firewall will look at that policy, will understand that that specific device, which belongs to the marketing division, doesn't have full access the same as the other user. It limits him from sending ICMP. Now the next thing you will need to do is to create a static route so that all packets from different interfaces will know where to go in order to get out to the internet. So to do so, you'll go to network static route, create new static route. Now I have already created one here. That's my static route. The destination is all zeros. That is, every packet that is destined anywhere and doesn't have a route in the routing table will go through that static route. You will need to choose the interface. In our case, that's the WAN interface, which is connected to our ISP router. We will not look at the administrative distance or the priority of that route, but know that you can actually prioritize different static routes on your Fortigate firewall. Alright, so we actually reached our final step, final configuration, which is applying security profiles to your policies. Now, you can find security profiles just beneath policy and objects, and you have different security profiles. Each security profile have its own knowledge base, and you can find dozens of videos in my channel that explains how to work with antivirus, web filter, DNS filter. The idea is now the idea is that you actually create a security profile and then you apply it on your policy. So let's just open one policy, let's edit it. And here you can find the different security profiles. Once you enable it, it actually scans the traffic and looks for viruses, malware, spam, domains that are not permitted, and other things. Application control is probably one of the most used security profiles out there. Now, each application in the application database has its own unique ID. It can be TeamViewer, Netflix, Amazon apps, or any other application. Now, your application sensor actually uses the IPS engine that looks at the different protocols, looks at the different traffic, decodes the protocol, looks for patterns, and then when it knows that a specific application flows through the different interfaces, it tells so in the session list. So let's take a look at how the application unique ID shows up in the session table. Alright, so the very first thing that we need to do is to head over to Fortigate Labs, Threat Lookups, Application Control. Now here we can look at the different unique IDs that each application has. Let's look at TeamViewer. Alright, we have different vulnerabilities, but we will look at the application category. And here we have TeamViewer, and let's just press it. And there it is. That's the unique ID of TeamViewer. The second app that we will look is Netflix. There we have Netflix, and Netflix has the unique ID of 18155. Alright, so let's move to our Ubuntu device. And let's just enable TeamViewer. Oh, there it is. All right, and it is working. So let's move back to our Fortigate. Let's just use the Diag sys session list. And we see that we have dozens of sessions. We cannot actually look at the different sessions, so we will use the grep command. And the very first app that we will look is the Netflix app, 18155. 18155. And there we have it. We have a session, that's the session ID. The serial is actually the session ID, and we have a session that actually the Netflix app actually uses. So that's the app ID. So let's get back to our Ubuntu. And let's look at the TeamViewer. It is working. And there we have it. That's the session ID, and that's the app, the TeamViewer app that actually initiated that session. Asymmetric encryption is being used just about everywhere. Let's look at the following scenario and then we will dive in and understand how it actually works. So let's assume that Eve wants to send a message to Bob. She writes down the message, she encrypts it using its own symmetric key, and then when it is all encrypted, it is being sent to Bob. Now, Bob knows the key. It knows the symmetric key that Eve used. He uses it, and by that, he actually decrypts the message. Now, if you think about it, we actually achieved only one thing. We encrypted the message. But then again, we have other challenges. The first one, how can we deliver the key between Eve and Bob? Let's assume that Eve and Bob doesn't live close by. The second challenge is how can we tell that the message wasn't modified? How can we tell that no one actually modified with the bits of the message itself? And the third challenge, how can we tell that the person who claims to be Eve is really Eve? For that, we have asymmetric encryption coming up. When Eve encrypted her message, she actually used asymmetric encryption, and the key that was used by the algorithm was known also to Bob. Let's just take a look at the terminal and let's just make it bigger, and let's generate a random key. So we'll use for that OpenSSL rand, which is a command that allows you to generate pseudo-random numbers, integers. Let's use a key in hexadecimal, and let's use an 8-byte key, and that is the key. That is the key that could be used in asymmetric key encryption and that both parties should be aware of. So if we get back to Eve and Bob, Eve used this key with its algorithm. It can be either AES, it can be DES, it can be 3DES, any symmetric encryption algorithm. And Bob used the same key. So both parties has the same key. They both know that the algorithm is either AES or 3DES, and the message could be decrypted on the other side. On asymmetric encryption, Eve actually generates two keys, key pairs. They may look similar, but they are actually different, mathematically related, but different. The first key is the private key. The private key is actually the secret key that Eve needs to keep in a secret place. The second key is the public key, and as the name suggests, it is public. Everyone can use that key. Now, when Bob gets the key, it can use it for asymmetric encryption and actually decrypt messages that were sent by Eve. It can also encrypt his own messages using the public key, and from there just send it back towards Eve and Eve can decrypt it. So if we'll go back to OpenSSL, let's just write down OpenSSL, GNRSA. RSA is one of the algorithms of asymmetric encryption, and we'll use the 2048-bit key. And that's our private key. That's our private key. We can actually generate the public key from the private key that we have just generated. But that's the private key that Eve has actually generated, and as we said, it should be kept secret. And there we have it. Eve generates a private key and a public key and sends the public key again to Bob. Now Bob gets its public key, and from now on it can decrypt Eve's messages. Now think about it. The fact that only his public key can decrypt Eve's messages suggests that the message actually came from Eve. That's one way to authenticate the other side. Now, in fact, asymmetric encryption is not used to encrypt the session itself, the data, the payload that is being sent from Eve to Bob and vice versa, for many reasons. One of them is the size of the keys. So what actually is being done is that the private and the public keys are being used to encrypt the session keys, the symmetric encryption keys. They are much smaller in size and they are being decrypted and encrypted much faster than asymmetric encryption keys. So Eve can actually generate a pseudo-random key that is a symmetric key, encrypt it using its own private key. Bob can get the encrypted message, open it with its own public key, and now he knows what is the symmetric key that Eve will use to encrypt the whole session. Auditing your firewall is a major task that you need to do from time to time. Now, there are companies that release tools that will allow you to audit your firewall, but here is the 10 best practices that you can start with. The following best practices are not in a specific order, so just use them as you wish. Now, another thing, I'm showing it on a Fortigate firewall, but you can also do it on a Checkpoint firewall, on the Palo Alto firewall, any next generation firewall. Quite obvious, but we do it on any device, any servers that we have on our organization. Be sure that your firmware is up to date. Always use the latest firmware. Usually the latest firmwares are much more secure. Your firewall vendor will always make sure that you have the latest patches on the latest firmware. So back up your configuration, look at the release path, and update your firmware. Encryption and high encryption is fundamental in your firewall. So be sure that you always use the strongest algorithms. Now, it's not always possible, but assuming that the other side also supports the strongest algorithms, just find out the appropriate CLI command on your firewall and enable it. So in a Fortigate firewall, it is config system global. Now it may change from firmware to firmware. Set crypto strong and just be sure to enable it. Always make sure that your administrator is connecting to your Fortigate through a trusted host. That is a trusted IP address as the IP address at its home or in the office. Now, you can do it using the graphical user interface. You can do it using the CLI. Let's do it using the CLI, config system admin. Let's edit the admin. And from here, set trusted host. And just write down the trusted IP address. If possible, on your WAN interface, your external facing interface, don't allow any administrative management. So let's just use the config system interface, edit port 1, which is my internet facing interface, and unset allow access. On your LAN interface administrative access, try always to use HTTPS and SSH, that is HTTPS to the graphical user interface and SSH to the command line. Now try to avoid ping and try to avoid other protocols unless needed. The following is probably one of the first audits that you need to do. Look for unused rules that were asked time ago and configured on your firewall. Look for them, and if they're not relevant anymore, just delete them. Now, a side note, document any rule that is asked. Document who asked the specific rule and the time that it was configured. Your administrator should always log into your Fortigate or any other firewall using HTTPS. So be sure that even if it tries to do it over HTTP, your firewall will redirect the request over HTTPS. So let's do it here. Config system global, set admin HTTPS redirect. Another setting that you should be aware of is the admin lockout and the admin lockout duration. Now that should comply with your organization policy. Config system global, and now let's set the admin. You can set the admin lockout duration. The default is 60 seconds, but you can set it to 5 minutes or more. That should comply to your organization policy. Now, another setting is the threshold itself. That is, the lockout threshold is actually the number of failed attempts, when your admin tries to log into the system. The default is 3, and it is a best practice to keep it at 3. Logs should be part of your auditing. That is, when you audit a firewall, be sure that logs are there for at least 7 days. Now, look at the proper documentation of your firewall. Let's just do it here. Config log disk setting, set maximum age. Now you can set it to 7 days, you can also set it to 30 days. It depends a lot where you save the logs, either on your hard disk or towards a syslog or any other device that has a proper storage. At last, let's look at some more best practices to hardening your firewall. One of them is when you have unused interfaces, disable them. If you have interfaces that you want to disable different protocol, so just disable them using config system interface, edit the interface that you want to disable, and there you can unset DHCP relay services, you can unset PPTP client, ARP forwarding, and so on. Another thing that is quite common to any FortiGate out there, and that is something that I'm not familiar with other firewalls which have maybe yes or no the same functionality, is what is known as the maintainer account. The maintainer account is actually a backdoor to your FortiGate. If your admin has lost its password, then it allows you to actually boot into your Fortigate using what is known as the maintainer account, which is actually the serial number of your Fortigate with the maintainer user. So you can actually disable it. In most Fortigates, I believe that it is enabled by default. Set admin maintainer account disable. If you have not used them before, then start doing so. Auto scripts are extremely useful on your Fortigate. Now, I've done already a video on how to do it using the security fabric automation section. Now, most videos that deal with auto scripts deal with the possibility to back up your Fortigate, but you can do dozens of things. You can clear the ARP cache, you can flash your DNS cache, you can reboot your Fortigate, you can of course back up your Fortigate, or even restart your IPS engine. Alright, so let's start. Alright, so to configure an auto script, you will move to your command line, config system auto script. Now let's name our auto script, let's name it restart IPS. Alright. Once we do so, we actually created a new entry. And the next thing to do is to set the interval between these scripts. We will use 1 day, which is 86,400 seconds. You can of course change it, but let's assume that we want to make it once a day. Alright, so the next thing is the repeat, set repeat. How many times do you want it to happen? Do you want it to happen 1 time, 2 times, 3 times? Now, you can do it only 1 time if you have something that needs to be done on the same day, that is, just enter the integer 1, or if you want it to be infinite, that is, every day that task will be running, so you will set it to 0. The next thing is the start. Now you can actually start it manually or start it automatically. We will choose automatically, that is, it will start without any intervention from no one. Now, if you're doing a task that needs some output, that is in terms of file size, you can actually determine the output size. Currently, we're only restarting the IPS engine, so we don't need that. The last thing is the script itself. Now, the script itself must start with double quotes, so let's set the script, double quotes, Diag test application. Now the application is IPS monitor and the number is 99. Alright, so let's configure another script, and this time we will clear the ARP table. So let's config system auto script. Let's just add it. Let's name it ARP-C for ARP clear, and let's set the interval, let's set it again to once a day, but this time we want it to happen only once. And the script, again reminding you that you have to begin and end it with double quotes, execute clear system ARP table. All right, excellent. So let's just end it and let's see the auto scripts that we have. So we have 2 scripts. The first one is the restart IPS, and the second one is clearing our ARP table. And again, you can use it for different tasks in different intervals, either to back up your Fortigate, to execute different commands. This is a fantastic tool. Automation is fundamental to every security appliance out there, and Fortigate is not different. Now, you can use automation in different ways. We will look at the security fabric automation stitches coming up. The idea behind automation stitch is quite simple. That is, it is very similar to if this then that. You choose a trigger and you choose the action that will follow. So let's create our first stitch. Let's name it reboot. The trigger is the machine that has just rebooted, and the action can be one thing or several things. We will choose two. The first one is CLI script. In the CLI script, you can actually write down any script. Let's just write down the most basic one, which is get system status. And the second thing that we want to do is to add up an email, so the output will be sent to the administrator email. Let's just write down the subject: machine has just rebooted. All right, so that's our first stitch. Now you can create stitches with schedules. So for example, you can create a backup stitch. Here we will schedule an event which will be the backup. It will happen weekly in 12 o'clock and on Sunday when no one works. Now the action itself will be a CLI script, and the CLI script will be the execute backup config USB. Let's name it backup. We can also add up the password for that backup. Now, the idea is that you actually can do a bunch of things using the automation stitches that will help you to offload different tasks as an administrator. So you've got your new Fortigate. How do you configure it? Coming up. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you've got your new Fortigate and your new two Fortigate firewalls. What do you need to do? You have probably connected your Fortigate using a network cable to your computer and configured it. Fortigate appliances comes with at least port 1, one of the ports, which is usually port 1, that is already configured with the IP address of 192.168.199. You need to configure your PC subnet to be on that same subnet, get to the IP address of the interface, of the port 1 interface, and from there you're actually starting to configure your Fortigate. Now you can configure a Fortigate using the graphical user interface, which has many features. It even has a feature visibility feature in the system settings, so that you can disable or enable new features which are not available over here. Now you can configure your Fortigate using the graphical user interface, and you can configure it using the command line. Fortigate experts use the command line almost all of the time. We will look at the command line, but we will make our way using the graphical user interface. To get to the command line, you need to click here. It is actually a JavaScript app that runs on top the admin web app. Probably the first thing that you want to do is to write down get system status, so you can see your Fortigate serial number, which ASICs, which accelerated hardware does it support. Are you using a hard disk or a flash drive? The current security profile database, and so on. Now, we went into the interfaces, you probably have one interface that you're connected to, which will be the management interface. Now you need to connect one of your WAN interface to your ISP, either through a modern router, or you can use your Fortigate as the router itself. Each interface has a physical switchboard that you can connect to different subnets in your network. Now let's just edit one interface. Let's see what's inside. You can name your interface according to the subnet in your local area network. Let's assume that we have a management subnet. All right, now you can define it a specific role. It can be a WAN, a DMZ, an undefined role, or a WAN. So let's use the LAN. So now we know that we have a management LAN connected to port 8 on our Fortigate. Now the addressing mode can be manual, it can be DHCP. Let's use the manual option and let's configure it to be 192.168.2.1/24 since we're using a 24 subnet. Now this address is the gateway interface address. So any computer that will connect to one of to port 8 will get an IP address in that subnet, that is the 192.168.2.0 subnet, but its gateway address will be 2.1. Now we will also open the DHCP server, so anyone that is connected, there's a pool of IP address that it will grab. We'll look at DHCP server very soon. Before that, we need to configure administrative access. Which protocol will support administrative access? We'll just use HTTPS and HTTP. For now, we can also use SSH. We can also configure it to support pings from host in that subnet or from a Forti manager, but we will not do it right now. LLDP is a protocol that enables discovery between devices in the network. It doesn't really matter. You can disable or keep it for now. Now we have a DHCP server. As I said, any client that connects to that port will receive one of the IP addresses from the pool. You don't have to use all the pool. You can use only 20 IP addresses. You can keep the DNS server the same as configured here, or you can specify your own DNS server. Let's just specify Google's DNS server. You can control the list time, and if you click on the advanced, if you have a DHCP server that is part of your domain, which is not your Fortigate or your Fortigate interface, you can configure its IP address here, and then whenever a packet arrives on that interface, it will head over to the DHCP server. But for now, we're using the gateway interface as the DHCP server. You can configure an NTP server. You can configure, and this option is for more advanced users, DHCP scopes or options. And you can assign different IPs to different devices based on their MAC address. Another option is device detection. Device detections allows your Fortigate to detect which device and which operating system devices on the networks belongs to. This is one of the things that you should keep enabled. Don't bother with the explicit web proxy. You can enable a captive portal. So if you have outsourced employees and you wish to jump a landing page with user credentials, you can also do that, but we will skip it for now. So this is the basic configuration of the interface. Okay. So now we have a management interface. We have another interface, which is the WAN interface that you connected. You connect it to your ISP router. We will call it WAN1. The role is WAN. We can use DHCP, and if we want to make it more reliable, we will use a static IP address. So my gateway interface is 10.0.3.75, and my router is actually 10.0.3.1. I've enabled HTTP and HTTPS, and as you can see, you don't have a DHCP server whenever the role of your interface is WAN. That is one of the best practices when using an interface as a WAN interface. Okay, so we have a management interface, we have a WAN interface. Now we want to make our managers that are connected to that port, which is port 8, to get out to the internet. So the next thing to do is to configure a policy. Now we will configure a very basic policy, which is a full access policy. Let's name it. Let's name it managers 1. And the incoming interface is management. That's the LAN interface of our managers. The outgoing interface is WAN1. That is the interface that is connected to our ISP router. That is the interface that takes them outside of the LAN towards the internet. Now when it comes to source, for this video, let's make it very generic. Anyone can go. Anyone. We can configure user groups and different users. We can also configure sets of parameters that control the different users. But for now, as for source, anyone can get out. As for destination, they can go just about anywhere. We can also create specific objects that will allow them to go to specific places, but for now they can go just about anywhere. As for scheduling, we're not limiting them to specific hours or days. So as for scheduling, again, they can get out to the internet any time of the day. As for service, we can deny them from getting out in specific services such as FTP, but for now, for our specific policy, we will let them use just about any service. Now, the action is accept. We can also create a policy that will deny specific services or specific users from getting out or from doing specific things. For now, the action is accept. Inspection mode is another topic that we will look into. That is the inspection that is done to our networks when we're using security profiles such as antivirus or IPS. For now, we will keep it at flow-based mode. Now, we will use NAT. NAT is Network Address Translation. That is our private IP address, which can be 192.168.2.6, will be translated to your Fortigate or to your ISP public internet address. Now we will not use security profiles. You know what? Let's use antivirus. Let's use the default profile, the default antivirus profile. We will use certificate inspection. When we use certificate inspection, your Fortigate checks the different fields that are coming from server certificates to see if they're valid, if it doesn't have any mismatches, and so on. The last thing is to use our logging options. We can log only security events, but we will log all sessions. So later on we can look at the login report and see what our users or what our host did. Okay. So we have a managers one policy. We have two interfaces. The WAN one, which connects us to the outsides, and the management interface, which managers in our company can connect to and get their IP addresses. That was the second step. Now the third step is to configure a static route. A static route is actually, for our usage, will be a default route. That is, I've already configured one, so let's just look at it. If you want to create new, you just create new. So default route actually tells your Fortigate that whenever he sees a packet, any packet that is destined to any place which doesn't have a route at the routing table, it will route it towards the WAN interface. And the WAN interface address is a 10.0.3.1. Remember, my ISP router has that address. Now you can use specific parameters as distance. You can use priority. It just tells me that I already have that static route, which I do. And once we have a static route, a policy, and interfaces that are configured correctly, we can now connect our host to the management interface, and those hosts can now get onto the internet. Let's just move to the CLI and let's see how do we configure interfaces using the CLI. So for the sake of our purpose, let's configure port 7. So using the CLI, we will use the config system interface. Now let's edit port 7 as we said. Let's set its IP to 192.168.4.1 with a subnet of 24. Let's set the management protocols to HTTP and HTTPS. And what else? We can use many more. If you will look at the, let's end it. Now I want to show you something. When you config system interface, let's just get out here. Config system interface, and if we look at port 1, for example, we can use the show full config, and as you can see, there are dozens of features of configurations that you can add. For our sake, we have only enabled the IP address on that interface, and let's look at it. Let's just refresh our page. Port 7, and there it is. Now we can also configure the DHCP server and so on. We have not done so on our CLI. The last thing I want to show you, once you get into your Fortigate, you're actually the Fortigate administrators. Now you have two types of administrators on, actually you have more than two types, but the two most common types is a super admin, which is you. You have privileges to just about anything. You can read and write, and you can create another type of administrator, which is the professional admin, where you can actually enable it, different read and write privileges on the different places on your Fortigate. If you will head over to the CLI and use the config system admin, and you can edit the admin name. I have two admins. I have one which is the super admin, and the second one which is offer test, which is my second admin. So now let's look at the different configurations that you can add to your admin. Again, lots of configuration. That's not the only place where you can configure different things. You can also configure it on a globally, which is the config system global. But one of the things that I wanted to show you is that you can strengthen your admin account by using a trusted host. So you can also look at it here. Here. You can configure a trusted host, that is a trusted IP address that only your admin can get from. So you can configure the IP address on your office at your work, and you can configure another trusted host, which is the IP address at your home. Only from those two IP addresses your admin can get into the Fortigate. You can also configure two-factor authentication, which is also a very common security procedure. You can use Forti token, and you can also use your email as a two-factor authentication. Let's just show you how to do so. Let's clear that out. So we can use the config system admin, let's edit the profile before, and set two-factor email, set email to, and let's set it to one of my Gmail accounts. Let's end it, and now if we'll go back to our admin profile, let's view it again, and you can see that you can now use an email-based two-factor authentication. When you configure a captive portal to one of your LAN interfaces, you can change and customize the look and feel of it. Coming up. So we have our LAN interface, which is connected to my Ubuntu device. So let's just open up the interface itself. And in network security mode, let's just choose captive portal, and let's choose a group that it is associated with it. Now you can choose your guest group, your outsourced employee group, just about any group you choose. All right, now when we head to our device, So let's enter Firefox, and that's what we get. We get the Fortinet logo and the background is gray. Now we want to change it, so let's see how we do it. Let's just get back to our Fortigate. Now to do so, you need to go to System Replacement Messages. Now you have two views, the simple view and the extended view. We'll use the simple view, authentication, login page, edit. Here you will see the image itself and the HTML part. Now we will not get into the different texts that are in the login page. You can change it, but let's see how we change the image from Fortinet to Forti-tip. Alright, so to do so, we'll head over to Manage Images. Let's create a new image. Let's name it Forti-tip. And let's upload the image that we have already prepared. You need to have an image which is less than 24 kilobytes. Alright, so that's the image. That's the name of the image. Let's name it Forti-tip 1, since I already have a Forti-tip image. Alright, so here is Forti-tip 1 and Forti-tip. Now let's get back to our login page. Let's edit. Let's just scroll the HTML page and let's find the logo part. Here's the logo part. Currently it is with a background, a gray background. So let's change it to all apps, that is white in hexadecimal values. And let's just change the image to Forti-tip 1. There we have it. Now let's just save it. And now we have a new login page, a new HTML page with our new image. So let's get back to our Ubuntu device. So let's start Firefox again. And there it is, the new logo, Forti-tip logo. And again, you can change the background as I did. You can change the different text that is within the login page. You can do many things with the login page. There are times when you need to back up your configuration and send it via email to another compliant Fortigate. Now, there is one thing that you need to add up to your backup configuration file. Coming up. So there's our use case. We have another Fortigate and we want to send it our primary Fortigate configuration. Now, the other Fortigate must be compliant, but we will not get into it. So let's look at the configuration file. That's the configuration file. Let's just open it. And there it is. Now, we don't want no one to tamper with our configuration file, to get into the file itself and change things. How do we do it? We make a checksum. We make a hash value of the configuration file and add up the hash value to our mail. So to do so, I'm using a Mac terminal, but you can use PowerShell. You can use just about any tool with the hash commands available. So in my case, it is SHA-SUM-A. Now, we need to choose the type of hash function. I'm using 256, but you can also use 1. In our case, it doesn't really matter. Now, let's just drag the file to our terminal, and there we have it. That's the hash value. That's the hash value of our configuration file. So the next thing to do is to copy it, open our email, and just be sure to add up the hash value of our configuration file. Now, the other side that gets the configuration file itself just grabs the file, makes the same operation, which is SHA 256 sum and the file path, it should get the same hash value. If it doesn't get the same hash value, then someone tampered with that file. There are different ways that you can prioritize your cloud apps over the other apps. One way is to use a traffic shaping policy. Here's how. The following scenario is quite typical for many businesses. Now, if you're using more than one WAN interface, you can use static route, create different static route to each WAN interface and prioritize different internet services. You can also prioritize the interfaces. You can even use SD-WAN rules and performance SLA. Now, we will look at a case where we have only one WAN interface, and we will do it using the traffic shaping policy. So the very first thing that you will need to do is to move over to your policy and make sure that application control is on. The second thing you'll do is to move to security profile, application signatures, and there we will create an application group for the cloud applications that we used most often. So let's just name it cloud apps. And from here we can actually use the category, which can be cloud IT, or we can actually select our applications. So let's use the AWS, which we used often. Let's add up Salesforce. All right. And let's add up Office 365. There we have it. Now, let's just save our application group. We can see that we have a new application group that includes all of our cloud apps that our workers use most often. The third thing that you will need to do is to create a traffic shaping policy. Now, if you move to traffic shaping policy under policy and objects, you will see that you have two main traffic shapers. One is the high priority and the second one is the low priority. Both are in the shared IP shaper. So let's move to traffic shaping policy. Let's create a new traffic shaping policy. Let's just name our traffic shaping policy cloud apps. The source can be all, destination all, service all, in application. Now here is the place where we actually use our application group. So just look for the cloud apps that we have just created. That's our application group. And here in the shaper, we will actually apply, let's just add up the WAN interface. And here we will apply the high priority shaper. We will apply it in both shared shaper and reverse shaper, so that we'll have also the downlink and the uplink with high priority. Okay, so we have a policy, we have a traffic shaping policy for cloud apps. So let's create another traffic shaping policy for any other apps. All right, again, source all, destination all, service all. Now you can choose the applications, but you don't have to. And here in the traffic shaping place, let's just use the low priority, both in the shared shaper and in the reverse shaper. And now we actually have two traffic shaping policy. If you enable application control on your policy, your application control sensor will actually notice whenever you use Salesforce or other cloud apps, and your traffic shaping policy will actually prioritize it over the other. Your Fortigate firewall is a session-aware firewall. It has its own session table, which can be seen using the get system session list. And there are cases when you need to tear down a specific session or the entire sessions that are on your Fortigate. How do you do it? Coming up. Your Fortigate is a session-aware firewall. It holds information on its session table and keeps looking at its session table every time a packet goes out through a different interface or gets into another interface. Your session table actually holds much more than this session itself. It holds the routes, that is, whenever your Fortigate does a route lookup, it saves the information in the session table. Now let's look at our session, get system session list, and we can see that we have dozens of sessions, some of them to the same destination. I currently have a Ubuntu device which is at the 10.0.5.4, and let's assume that I need to clear out all session. So the command for that is Diag session clear. Don't do that. Don't do that. It's quite dangerous to clear out all sessions that are happening on your Fortigate. Instead, we will use the filter option. Now you can filter out different session either by source interface, destination interface, source, and even protocol, which is quite interesting. Now we will use the source. So let's use the source, which is the 10.0.5.4. And the next thing to do just after that is the Diag session clear. Once you do so, just press the enter, and specific sessions, the sessions that you have filtered, will be terminated. Your Fortigate uses its memory for the different processes, either IPS, antivirus, or general functionality. Now, when it reaches your memory threshold, it gets into what is known as a conserve mode. How do you control it, and how do you decide which operations takes place when you enter conserve mode? Coming up. Getting into a conserve mode is not a desirable thing. Now, there are actually 3 thresholds that you can actually configure by yourself, and those thresholds determine when you enter a conserve mode, when you exit from a conserve mode, and when the sessions are being dropped as you're entering an extreme threshold. So let's take a look at it. Let's just stop our Diag system and let's config system global. And in config system global, you can actually set the different thresholds. Now, the extreme threshold is actually the threshold or the percentage of total memory when your Fortigate starts to drop a session. You can also set the green thresholds, which is the thresholds where your Fortigate exits from the conserve mode. And there's the red threshold, that is the thresholds when your Fortigate enters conserve mode. Now, when your Fortigate enters conserve mode, something happens. The first one, your Fortigate doesn't accept any configuration changes. The second thing, it doesn't execute any quarantines. Now, there are other things that you can configure as sessions on your IPS engines and antivirus. So let's just get out of the different thresholds. Config IPS global. Set fail open. Now you can decide either to enable fail open or disable. If you enable IPS fail open, packets will still flow, will still go through the different interfaces, but with no IPS inspection. If you choose to disable it, The packets that require IPS inspection will be dropped. Now, if you want to check if you're in the conserve mode or not, you can just use the Diag hardware sysinfo conserve. If you do so, you can see that you're currently not in a conserve mode. If you were in conserve mode, you would see the on instead of the off. And you can also see your total RAM and the memory that is being used. You can also see that the threshold for the red extreme mode is actually 95% of total RAM. You will enter conserve mode at 88% of total memory, and you will exit from conserve mode when you get down the threshold of 82%. How do you control data consumption and bandwidth when everyone is at home? Coming up. To take control over data in COVID-19 times, we can use the traffic shaping policy in our Fortigate. So let's move to policy in the objects, traffic shaper, create new shaper. Now we can use a shared shaper or we can use pair IP shaper. So let's use pair IP shaper. Let's name it COVID-19 streamer. So we'll know that it is for our streamer device. Now the maximum bandwidth, we will limit it to 30 megabits. And let's save our shaper. The second thing to do is traffic shaping policy. Let's move to traffic shaping policy, name our policy COVID-19. Now the source, we will need to create an address object for our streamer, so let's just do it. Let's streamer 1, since I already have one, 10.4.10.0.4.9/32. Okay, so we have our streamer device as our source. Destination is all. Now we can use specific applications such as Netflix and so on, but we do not want to limit our streamer device only to streaming applications. We want to limit the traffic as all. So we will not use the application or the URL category, but we will use in outgoing interface the WAN interface. And now we'll use the pair IP shaper. Select your traffic shaper that you have just configured. And that's about it. Crypto mining malware or cryptojacking is a form of a malware that actually uses your own resources to mine cryptocurrencies. Now, the attack vectors, the way that the crypto miners gets into your organization can be either from botnets, it can be from malwares, it can be from JavaScripts that runs on your browsers. Now, as we've seen in the last several years, it can run on your routers, it can run on your PCs, on your Android smartphones, or on your servers. How do you protect your organization from crypto mining malwares? Coming up. Crypto mining software comes in many forms and can actually get into your resources from different locations. So how do you block them? Well, there's no one recipe. You will need to apply different security profiles. The first thing to do is to apply the antivirus security profiles in your policy. Why? Because Fortinet has actually included different signatures for crypto mining software. So if you're using either the normal database or the extreme database, just apply them to your policy. The second thing is to block different crypto botnets, and there are dozens of crypto botnets out there. So be sure to block botnets on your botnet package. The third thing to do is to block different applications that are related to cryptocurrency. How do you know which applications to block? Well, you can head over to the Fortigate Labs and just look for cryptocurrency. There you will find different applications that actually tries to mine different cryptocurrencies. So the thing to do is to open your application control, and in the application override, just find the different signatures and block them. The other thing, as we said, there are different JavaScripts that run on your browser, and you will also need to block them using your IPS signature. Which signature is that? So again, move to your Fortigate Labs, look for the different cryptocurrencies signatures, but if you want to be just a little bit more precise, look for javascript.cryptocurrency. And there you will find different generic JavaScripts that can run on your browser, and you need to block them. So just copy this one and block it on your IPS engine. On the following scenario, I will use the author microcontroller after connecting to it through the pwned SSID, and de-authenticate, send de-authenticate and de-associate frames towards an access point. Now, do it on your own risk. Do it only on equipment that you're allowed to do so, probably your own equipment. This demo is for educational purposes only. Alright, so to connect to the author page, we will head to the pwned SSID. Just type 192.168.4.1, and here we have several sections. The first one is the scan section, where the author actually scans the air for either access point or stations. Now we will select the access point, our access point that my TV, my other devices are connected to. Just select it and move over to the attacks section. Now there are several attacks. We will use the auth attack, and let's start the attack. But before we do it, let's just open up Wireshark and let's capture the air so we can see what is actually happening. So let's start the attack. And let's move back to our Wireshark, and as you can see, we have tons of the associate and the authenticate frames that are actually being sent. So let's stop the attack itself, and let's select the, let's just open the frame itself. Let's open the frame itself. Let's look for the associate frame, and we can see that it is being sent to the broadcast domains. So every station that will try to connect to our Wi-Fi access point or wireless router will actually get a de-authenticate frame and a de-associate if it is already connected to. When you want to get around your system admin, you can use the decoy technique in Nmap to scan the subnet that you're connected to, or the gateway that you're connected to. So we have our Ubuntu device, which is connected to the 10.0.4.1 subnet, and its IP address, let's just check it out. Let's use the ifconfig. The IP address of our Ubuntu device is the 10.0.4.8. So let's use the decoy technique and let's see how that looks in Wireshark. Alright, so the first thing to do is to open Wireshark. Let's capture traffic, And now let's move back to our Ubuntu device. All right, and for that we will need root privileges, so we'll use the sudo. Let's use the full SYN scan, which is SS, and the target is our gateway, which is the 10.0.4.1. I remind you that's the gateway that our Ubuntu device is connected to. And the other thing to do is to use the decoy technique with the hyphen uppercase D. And let's presume that we are coming from the 10.0.7.33. All right. Now we get our results. We can see that we have HTTPS open. Now let's look at Wireshark. Let's close our capture and let's use the IP ADDR equal 10.0.7. Let me just take a look. .33. And there it is. Although our IP address was 10.0.4.8, that was the Ubuntu address, we used the decoy technique in Nmap to pretend to be the 10.0.7.33 and get information on our gateway. Now let's use the same one to get information on our WAN interface. And now let's use the 32. Let's just open Wireshark again. And here we have it. We can see that our gateway is actually quite open in terms of ports. Just about any port is open here. So that's definitely a vulnerability issue. But let's just open up Wireshark and let's stop our capture. And this time it is 32. So there we have it. Our Ubuntu device is trying to connect, is actually connecting to our WAN port. And to the right, we can see that our client is actually sending a SYN packet without sending back the acknowledgement. So let's create a system interface and a DHCP server using the command line. The following is part of the basic firewall training. We will set up an interface and a DHCP server. Let's do it on port 4. We will do it using the command line. So let's just use the config system interface. All right, let's edit port 4. Let's just make it port 4. Let's set the IP to 10.0.7.1/24, and let's set the allow access, the management protocol access to ping, HTTP, HTTPS. We can also set the weight for that interface. Let's just give it a weight of 250. We can set different settings for that interface, but we will end with that will be our local area network interface for our finance department. Now the second thing that we can do is to actually configure a DHCP server on that interface. So config system DHCP server. Let's edit that server. Let's create an entry, a new entry, and let's set the default gateway for that DHCP server to the 10.0.7.1. And let's also set the interface. We're creating that on the port 4 interface. Now let's configure the IP range, the pool of IP addresses that it will list for the clients that connect through that interface. And for that, we will use the config IP range. And let's also use edit one. And let's set the start IP at the 10.0.7.2. And let's set the end IP to 10.0.7.11. All right, next, and let's set the net mask to 255.255.255.0, that's /24, and let's set the DNS service to default. All right, now let's end it, and let's just refresh our page. Remember port 4. Let's refresh it. There it is. And here we can see that we have our LAN at port 4. That's our finance LAN. That's the IP of the LAN gateway. That's the administrative access. And here's our DHCP server that starts with the 10.0.7.2 up to 10.07.11. And the DNS server is the same as the system DNS. 2 minutes CLI commands, and this time the Diag sniffer coming up. Diag sniffer packet is one of my favorite commands. Why? Because it actually allows you to packet capture the traffic, sniff the traffic just as TCP dump or Wireshark does. So the syntax goes like that: Diag sniffer packet, and then you need to include the interface. So we will do any, but you can choose port 1 or port 2. After that, you actually filter the traffic. You can filter it using the source destination protocol. We'll use the host, so we'll use the host 10.0.3.1, which is my gateway. Next comes the verbosity, that is the amount of data that you want to include. I will choose 4. And we can also add up the count, that is the packet count. So let's add up 10 packets. And if you want a timestamp, you can add the A letter. So let's start. And there we have it. Now you can play around with the different filters and the different verbosity levels. Do that. If you want a packet capture, not using the Diag sniffer, but using the graphical user interface, you can do it in network packet capture, and in packet capture you will find that you can choose the interface and use the different filters. We have already learned how we can list system processes and show their output on the command line. Now on this video we will look at how we can kill different processes that consumes too much memory or too much CPU power, and how we can list the highest demanding processes on our Fortigate. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you're using a high-level encryption in your VPN, you're using IPS to scan different patterns and anomalies, you're using antivirus, and you keep logging of just about anything. Well, all of that consumes lots and lots of CPU resources and memory. Let's take a look at the Diag system command. Let's make an interval of 20 with 10 processes. Alright, now using the M character, you just need to type the M character. We can sort out the processes that consumes the highest memory and in our case it is the DNS proxy. If we press the P character, that P is for CPU, we will see the different processes that consume the highest CPU resources, and in our case it is HTTPS daemon. Now the next step is to kill the process that causes you lots of issues. That is the last step before you reboot your Fortigate. Let's do a Control C. To kill a process, you use the Diag sys kill. Now you enter what is called a signal. That is a term that comes from Linux and Unix, which is actually a polite way to ask your system to stop the process, and it can be a more aggressive way to tell your system, it depends on the number, to tell your system to kill the process. Now we can use different signal numbers. We will use 15, which is an aggressive way to tell your system kill that process, and we will list the process ID. Now the process ID, as we know, is the second column. So let's use the DNS proxy process, which is 94. Alright, now we have just killed that process. And here we can see that the DNS proxy process has actually been terminated. We saw that we can list processes, sort them out, and even terminate them whenever they demand too much resources. On our last part of knowing your processes, we will see how we can, in one CLI command, see the top most CPU demanding processes. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. One of the features that we saw using the Diag systop command is that we can list the most demanding processes, either CPU and memory, using the M and the P character when it is pressed. Now, there is another command, which is the get system performance top, which lists only the most demanding CPU processes. Let's see it in action. So we use the get sys, sorry for that, get sys performance top. Now you will see the most demanding processes, the most CPU demanding processes at the second most right column. That's the CPU column. The most right column is, as we know, the memory column. Now you will see different processes such as the IPS engine or the antivirus scanner, new CLI, or even the SSHD, the SSH daemon. Now, whenever a process is too demanding in terms of CPU, you may need to kill that process, and we saw how to do it using the Diag sys kill with a signal level and the process ID. If you're using one of Fortigate's latest firmware, then you will find out that the DLP, the data leak prevention, is not there anymore, at least not as a graphical user interface. Now, parts of it went to the web filter. You can actually use the file filter and block different types of files. But credit card and social security numbers blocking or logging can only be done using the command line. So let's take a look at how we configure a credit card sensor using the command line. Coming up. Credit card sensor matches numbers from credit cards. Those can be from MasterCard, Visa, American Express, and so on. Now, it can be used with files or with messages, that is, email messages. So let's configure our first credit card sensor, and let's start by config DLP sensor. Let's just edit. Let's create an entry and config filter, and our first filter will be number 1. All right, so let's skip the name of the filter. Let's set the type to message. We can also use files, but we are actually using now messages. And let's set the protocol. Now, since we're aiming at email protocols, those will be SMTP, POP3, and IMAP. All right. Now let's set the filter by credit card. You can also use social security number, or you can actually use regular expression if you're looking for specific patterns in the text itself. But we are using a credit card sensor. Let's use next. Let's end it, and let's set DLP log to enable. And that's it. That's how you create a basic credit card sensor. Now, there are other options that you can choose from, such as sensitivity and so on. So I urge you, look at the CLI reference and configure it the way you want. Let's look at some specific DNS settings that will make a change in your network. Coming up. You can configure your system DNS settings under the network DNS, where you can specify your DNS server's IP address. You can even set it up to work over TLS, which is a topic that I covered before. But let's look at the command line, and let's look at two configurations that are important. So let's config system DNS. Now here you can set up the primary DNS server or the secondary DNS server. Let's just set the primary to be Google's DNS server. And two configurations that are important are the cache time to live and the cache size. So let's set the set DNS cache limit, that is the amount of records that can be saved on your cache. By default, it is 5,000, but you can set it up to a much higher number. That depends on your needs, but I have found that 5,000 records are quite enough. The other configuration that you need to look for is the set DNS time to live. Now, the time to live is the amount of time that the DNS record is saved in your cache. That is the DNS response that you've got back. Now, it is being saved on your cache. It actually serves you faster since it comes from the cache. It is much faster. It doesn't need to go all the way to an authoritative server. The default is 1800 seconds, which is 30 seconds. The maximum is about 86,000 seconds, which is 1 day. Now, 30 minutes, as we said, is the default, but let's set it up to 1 hour, 3,600 seconds, and let's end it. And now let's just refresh our page. And there we have that our primary DNS server is the Google's DNS server. The secondary is actually FortiGuard servers. Now, one thing to note, if you for any reason need to clear your DNS cache, you can do it quickly using the Diag test application DNS proxy. Now look at, once you press the enter button, you will see that you have different options. So just use number 1 and you will clear your DNS cache. If you create a VLAN on a physical interface, then you will notice that the VLAN actually inherits the physical interface MAC address. Let's do it and let's see it in action. So we have an interface, that's the finance interface at the 10.0.7.1, and let's create a new interface, a VLAN. Let's just give it a VLAN ID of 100. Let's name it finance outsource. Now the interface that it will sit on is the finance interface. Let's give it a unique IP address, its own broadcast domain at the 10.0.8.1/24, and enable the DHCP server. All right. Now, when we do so, we can actually see that our MAC address on the finance interface is this MAC address, which ends at BE. Now, if we look at the VLAN interface, let's just edit this one. That's the same MAC address. It's not so frequent, but there are times when you need a unique MAC address for your VLAN interface. You do it using the enhanced MAC VLAN. Coming up. Alright, so to configure an enhanced MAC VLAN, your VLAN has to have a unique ID that is unique even if the different VLANs are on different VDOMs. Now you can implement it on a multi-VDOM environment, on a single VDOM. So before that, I've already deleted the finance out VLAN, and let's just take a look again at the MAC address. That's our MAC address, 6DBE at the end. So let's configure a new VLAN. For that, we'll use the config system interface. Let's name our new VLAN. Let's name it finance out. All right. And now let's set the type. If you use your tab key, you can actually move between different interfaces, the same as you would do on the graphical user interface. But here you will also have the eMAC VLAN, the enhanced MAC VLAN. So let's just press enter. Now let's set the VLAN ID to something that is unique. Let's just use 120. Let's set the VDOM to the root VDOM. And now let's set the physical interface, which is actually, that's port 3. All right. Now let's just refresh our page. Let's move to interfaces, refresh them. And let's look at the finance interface. That's the finance interface. So the finance interface starts with 000C29, and our enhanced MAC VLAN interface, let's see, starts with 06. So the MAC address, although it seems similar, is actually different. So you have your LAN set up, your WAN interface set up, you have your static route and your policy. Now it's time to fine-tune your security profiles. Coming up. The following is not a recipe or a cookbook, it's all about fine-tuning tips for your security profiles. So let's start with the antivirus. Now you can configure your antivirus settings using the command line. Let's just get out of what is already on the screen. Config antivirus settings. And from here you can choose, let's just show the full config, you can choose the different databases that you wish to work with. So set default database and you can move between normal, extended and extreme. Be sure to also set the grayware to enable. Grayware are actually apps that are not by definition viruses or malwares, but these are apps that can harm and decrease your performance, such as adwares. The second thing is web filter. Starting from 6.2 or 6.23, you can now block different file types. So you can block zip files, you can block PDF files, you can block Excel files, you can block them on different protocols. So be sure to do so. Another thing about web filtering is that you have proxy options. Be sure to enable proxy inspection mode on your policy. On DNS filter, you can block different botnets, but the thing about DNS filter is that you're actually blocking a domain. You're not blocking a URL. So you cannot block a subset of a domain, which is a URL, but you can block the full IP address or the full domain. So this one will work much faster on your Fortigate than web filtering. So be sure to be aware of that. In application control, you can actually block, override, enable different applications based on their categories. You can also block a category and override a specific application that belongs to that category. You can do it here, application and filter override. You can, and it is a best practice to block quick as Google's new protocol, since it actually influences your Fortigate performance and capabilities. Moving on to intrusion prevention, be sure to use IPS, create different and customized signatures if you need, but the most important thing to do is to configure your signatures based on the filtering options. If you're targeting clients, be sure to use the client filter. If you're targeting servers, if you're targeting different severity levels or different protocols, be sure to customize your IPS signatures based on the topology on your organization. Now, this is only the tip of the iceberg. There are lots of other configurations that you can do, such as config antivirus heuristic. You can use your web filtering with deep SSL inspection to log just about any keywords that your employees are looking for. You can use application control to enforce protocols on specific ports, and so on and so on. You can create customized signatures for specific events or specific anomalies that you're looking for. You can create a denial of service policy that is based on different anomalies, but be sure that it will be productive for your purposes. Firewall rules are basically the bread and butter of every firewall out there. It doesn't really matter if your firewall is a next generation firewall. Whenever you head out to the internet and you're using a firewall, then you're obliged to firewall rules. What are firewall rules and how are they made? Coming up. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. A firewall rule is nothing more than a set of criteria that your traffic needs to match. Whenever an IP session happens in your network, a set of rules are being matched against that traffic. If your firewall doesn't find a match at the first rule, then it goes to the next rule. Rules are handled from top to bottom. Now let's look at how a policy rule is being configured and what objects are used to create that match. In every rule, there's always the implicit deny rule that sits beneath every other rules. That is, if your firewall doesn't find any match in the traffic, then the traffic goes to the implicit deny rule and it is being dropped. So when we start to configure our firewall rule, we have, as we said, an implicit deny rule at the bottom. And from there, we start to configure our different criteria that will be matched against your traffic. Now we start with the name of the rule itself. As for naming conventions, don't use too many characters, don't use spaces between words, try to use underscores. The second thing is the incoming interface. What is the incoming interface? Well, that's the interface that your local area network is connected to, your DMZ is connected to, whatever interface that the traffic is coming from. The second criteria is the outgoing interface. So that usually in a full access rule, full access policy, that is your WAN interface when you configure your rule to allow traffic from the LAN towards the WAN and the internet. But it can also be another segment of your enterprise, another LAN. It can be the DMZ. The incoming interface is known as the ingress interface. The outgoing interface is known as the egress interface. So we have two interfaces, the incoming interface, the outgoing interface, and from there we move to the source. What is the source that makes the traffic? Well, that can be your clients. That can be just about any source, that is any IP address, or you can use what is known as firewall objects as specific IP addresses within your local area network. It can also be a user or a user group that is saved on your firewall internal database or a remote authentication server such as LDAP or a Radius server. Another criteria is the destination. What is the destination that your traffic is heading towards? It can be any destination, that is any IP address out there. It can be a specific IP that you can configure, or it can be a domain, or maybe an internet service, an Amazon service. So be sure to be granular. Don't just use any or all. Be specific. If you're configuring a full access policy that will allow anyone to get out towards the internet, then it will probably be all. If you're configuring specific destination, then be sure that to configure them ahead and use them in your rule. The next thing is scheduling. Do you want your policy to work out 24/7? Or do you want it to work on specific hours, specific days, reoccurring days? So you will probably have cases where you will be asked to open a firewall rule for a specific appliances in your local area network. It could be a backup device, it could be a network attached storage. Be sure to know what times are those appliances need that firewall rule. The next thing is service. Service, that is, which protocols are being used in your firewall rule. Are you using only HTTP, HTTPS, and DNS, that is port 80, port 443, port 53, or are you allowing your employees to get out to just about anywhere using any protocol out there, including FTP, SSH, and so on? So again, be careful with the service usage rights. And the last thing is the action. Are you denying or are you allowing traffic based on that match? Now, this was actually only the part one of your policy or rule creation. The next thing, once you have a match, is to go through security profiles. That is going through antivirus, application control, IPS, and so on. The other thing that you will have to take care is, are you using network address translation? Are you logging all sessions or only security events? If you look at my channel, you will find dozens of videos related to security profiles and other features of your firewall. So please check out, subscribe, and see you soon. One of the most basic security measures that we all do, especially now, is to block specific countries. That is, using a geolocation and block those specific countries. Now, most of us just create an address object, a firewall address object that is of type geographic, and then apply it to a deny policy. But that's not enough. To make your policy bulletproof, you will need to apply a local in policy. Coming up. When you create a security policy on your Fortigate, you actually control the traffic to and from your Fortigate. That is traffic that comes from the ingress interface to the egress interface and vice versa. Now, your Fortigate actually has another type of policies, which are the local in policies. Those policies actually restrict or enable user access to the internal traffic, that is the management traffic. How do you see the local in policies? You can head over to System, Feature Visibility, and here in Feature Visibility, let's look for the local in policy. Apply that. Once you do so, move again to the Policies and Objects, Local in Policy, and there you will see the type of protocols that are allowed for administration, for routing, for central management, and more. Now, remember, if you create a firewall address object, then you're actually denying it only on the security policy level. You need to deny access also on the local in policy. So let's start by creating an address object. Let's create the policies, and then let's create the local in policy. The local in policy can only be configured through the command line. All right, so let's just head over to policy and objects, addresses. Now, we can do it over the command line also. Config firewall address. Now let's add it and let's name the country that we wish to block. For the sake of demonstration, let's just use Iran. Now, the type of address is geographic, so we need to set the type. You can scroll between the different types. Now, geography is the type, so we will choose geography. And the next thing to do is to set the country. Now, you need to set the first two letters. Now, each country has its own characters. Now, you probably don't know which are which, so just type a question mark and you will see the different countries and their first letters. So let's just look for Iran, Iraq, Iran. So IR is the initials. All right, so let's set the country to IR and let's end it. Now, once we do so, again, we can go to the addresses and here we will find Iran. That's the firewall address object that we have just created. All right, so now let's move to our policy and let's create a new policy. Let's name our policy block country. The incoming interface is our marketing interface. The outgoing is our WAN. So we will block it using two policies. One is for the inbound traffic and the second is for the outbound traffic. The source is all, that is everyone in the marketing local area network, and the destination is the firewall address object that we have just created, that is all service and all time. So scheduling is always, and we will deny. So that's a deny policy. So we have done that on the internal LAN interface. Now let's do it from the WAN side. Okay. Let's name block country in. So our WAN interface would be used as the incoming. Our marketing interface is the outgoing. Source Iran and destination all. Service all, and again deny. So we have two security policies, one for the inbound and the second is for the outbound traffic. All right, and so now we need to create a local in policy that will deny access from a source address, which is Iran. All right, so to do so, we will need the command line. Let's just clear the page. Config firewall local in policy. Let's edit number 1. Let's set the interface. Currently my WAN 1 is at port 1, so we will use port 1. Let's set the source address to Iran. Let's just look for Iran. There it is. That's the source address. We're trying to protect traffic that is coming from Iran. Let's set the destination address. Let's do it all. Let's do it all. And let's set service. Currently, we will also use, just 1 second. Let's set the service to all. All right. And let's set the schedule to always. And that's it. All right. So we have created a local in policy that will protect our internal traffic. And now let's just look at that again. Let's see what we have here. All right, so that's all for now. Now, if you're using VIP, if you're using virtual IP, you will need to match those to the policies, since VIP actually takes precedence over the IPv4 policy. That's all for now. Please subscribe and press the bell notification so you won't miss anything. The following scenario is as follows. You have your local LAN users, you have your access point that is broadcasting its signal in the air, and you have an outsourced employee that starts to work at your organization, and you want to create a guest user. How do you do it? Coming up. Creating a guest access involves several steps. Now remember, a guest access is mostly an account that has a limited time period. So let's start with a user group. Let's create a new group. Let's name it guests. And the type will be guest. Now from here it's quite self-explanatory. The user ID of the guest will be its email. Now you can use an auto-generated password that your Fortigate will generate, but let's use specify, and when we will create a new user account you will see where to enter it. Now you can add up sponsor, you can add up company, and the period, let's add 24-hour period. So our account period will be 1 day. Now the next thing to do is guest management, where we create our user account. Remember, our user ID is the user email address. Now let's add up the password. Let's add the email itself. The company will be Forti, and let's just make sure that the expiration time is 1 day. The other thing that you need to do is to create an administrator that will handle the guest account. Let's name it admin guest, and let's add up its password, a simple password. Now the profile will be professional, and just choose the restrict admin to guest account provisioning only, and the guest group is the guest that we have just created. Now if we log out, let's just enter again as our admin guest. Let's see what the admin guest sees when he enters your Fortigate. Well, that's the thing that he sees. Well, that's what he sees. He sees the different accounts. He can add up new account. He can delete accounts. So let's log out and let's enter again. Okay. The last thing to do is to add up a captive portal to the interface where your outsourced employees will connect through. That's our interface. Security mode, captive portal, and restricted to the guest group. Okay, so now we have user group, we have created the user account, we have chosen the password, but the password can be auto-generated and sent to our user email. And now let's move over to our Ubuntu device, which is connected to our interface. And from here we have the captive portal. And there we have it. The following video is dedicated to beginners who are just starting to administrate their Fortigate. This is a free 15 minutes masterclass. So let's start. So here we have the Fortigate administrator page. You can configure the different settings either by using the graphical user interface or by using the command line. We will mix between the two. I can tell you that using the command line you will have access to much more advanced settings. Now, as for methodology, we will start with the administrator account. We will move into creating new interfaces, creating a static route, creating a policy that will match the traffic and will choose either to deny the traffic or to allow it. Then we will move to our security profiles. We will see how we can configure the antivirus, the web filter, application control, and so on. And from there, we will move into different settings that will make configuration much more strict into our purposes. So let's start. All right, so the very first thing to remember is that you're the administrator of that Fortigate. You have lots of responsibilities, starting from backing up the configuration and creating policies, interfaces, different settings, different authentication rules for your users. Now, if you will go over to System Administrator, the very first thing that you will need to do is to harden, make your account much more strict by using either a Forti token and trusted host. So you can actually configure specific IP addresses that you will log only from there. You can do it either using the graphical user interface or by moving into the command line. Here we will use the config system admin, and let's just edit the relevant profile, which is admin. Now here we can set different configurations to our admin profile. If we use the show full config, we will see the full configuration, either setting up trusted host or even setting up a two-factor authentication by using an email account. That is possible only on the command line. Alright, so we have our admin account. So now let's move over to network interfaces. And this is the topology that we need to configure. This is a very basic SMB topology. You have your LAN, which is connected to one interface on your Fortigate, and you have your DMZ, where your server sits, which is connected to another interface, and you have your ISP router, which is connected to your WAN interface on your Fortigate, which is this WAN interface. So let's start by configuring the LAN interface and the DMZ interface. So choose your interface of choice, edit. Now name your interface. I will name it LAN, and choose its role. Different roles means different settings, but our role currently is LAN. We will configure the IP address of the gateway itself, that is 10.0.4.1/24. Another thing that we need to configure is the administrative access. We will use HTTPS to connect to that interface. We will also allow ping, and we need a service, a DHCP service that will run on our interface, so that hosts that will connect to our interface can ask for IP addresses, and we will apply that using the pool, which currently is up to 254. We will set it to only 50 IP addresses. You can head over to the more advanced DHCP server and assign scopes, assign specific IPs to match your host's MAC address, but we will not do so. Device detection allows your Fortigate to actually detect the type of devices that runs on your network. That is either an Android, a Windows PC, a Mac computer, and so on. It does so by looking at its MAC address, user agent, TCP fingerprint, and other methods. You can also enable captive portal on your interface. We will not do so. So that's it for our LAN interface. And now let's configure our DMZ interface. So let's edit it, name it DMZ. Now the role will be DMZ, and once you do so, you will see that you don't have a DHCP server on that interface, since as a best practice, do not allow DHCP service on your DMZ. So let's configure its IP address, 10.0.5.1/24. We will only use HTTPS as our administrative access, and that's it. Now we have two interfaces. One is dedicated to our LAN, and the other one is dedicated to our DMZ, our WAN interface. Let's just edit and name it WAN so it will be easier when we configure our policy later on. All right, so now we have our interfaces set up, and the next thing to do is to manually configure a route entry that will allow all packets to flow towards the gateway interface, that is our WAN interface, and from there to the internet. So we'll move to network, static route. Let's configure a new default route. Our gateway interface sits on the WAN interface, and its IP address is the 10.0.3.1. We can determine the priority of our static route and its distance using the following configuration, but we will not get into it. You can see I have dozens of videos that are dedicated to the different routing attributes of your FortiGate. Okay. So now we have one static route which actually tells different packets that if you wish to go to just about any destination that doesn't have its own routing entry in the routing table, move to the gateway at the 10.0.3.1 using the WAN interface. And now let's move and see our new entry, our new route entry that we have just configured. We will do so using the command line, although you can do so also using the graphical user interface. So get router info, routing table all. And there you see you have a new static route that actually points to the default route via the 10.0.3.1 IP address. All right, so we have our interfaces, we have a static route, and the next thing to do is actually to create the policy itself, the policy that will allow packets to flow from interface to interface by matching the traffic and seeing if it is denied or allowed. So to create a policy, we will move over to policy and objects, IPv4 policy, and create new. The first policy that we wish to create is a policy that will allow everyone in our LAN to get out to the internet using any service at any time. So let's just name our policy full access. The incoming interface is our LAN interface. The outgoing interface is our WAN interface. The source, we will not limit users, so we will just allow anyone to get out. Of course, if you need more granular control over your policy, you will create firewall address objects and you will define which one can get out and which one cannot. You can also create user groups and users. Destination, all. We are not limiting the traffic to a specific place. Anyone can get out to anywhere. Scheduling, always. Service, again, we can limit it to specific protocols, but we will keep it to all. Now, the action is accept. The other thing to note is the inspection mode, which we will look at when we create security profiles. We want our traffic to be netted. That is, our traffic currently happens on our private IP addresses, but when we go out to the public internet, we need to translate our IP addresses to the public front interface of our Fortigate. So that's what we will do. And we can configure the different security profiles. We will do it very soon. Now, in terms of logging, we don't want only security events to be logged. We want all sessions to be logged. So we will enable all sessions. Okay. So now we have our first policy, which is the full access policy. All right, so now let's create our second policy for the DMZ. And from the DMZ point of view, let's just allow traffic that comes from the internet towards the DMZ. From for our purpose, let's just make it from anyone, but in your environment, just configure it based on your needs, security policy, events, and so on. Destination. All we can, of course, configure a specific. You know what? Let's just configure an address for our server. Let's assume that we have a web server that anyone can access using HTTP and HTTPS. So let's name it web server. We will use the 10.0.5.4/32. So we will so it will point out exclusively to that web server. Now the service can only be HTTP and HTTPS. We will use the different security profiles and we will log all sessions. Okay, so we have a second policy that is towards our DMZ, but now the traffic comes from outside towards a specific web server, and we have only allowed the HTTP and HTTP service. Now, once you finish up with your different policies, you will need to apply the different security profiles. For that, you will move over to security profiles, choose the one that suits your security needs. You will probably choose antivirus, web filter, maybe application control if you want to control applications that your users are using. And once you create a security profile and name it, you can enable it in your policy by going to the policy page and select which profile is needed. All right, now the last thing to do is to move to your system settings and choose the appropriate settings that will make you feel good while you administrate your Fortigate, either in terms of how much time do you want your idle timeout to be, how do you want to customize the look and feel of your Fortigate, and do you want to use any other email service other than the FortiGuard email service. So you can do all that. Now, we have actually looked at the basics of putting up your Fortigate in a typical scenario. If you want to learn more, please subscribe to my channel. I regularly upload 2 to 3 videos every week. When you have different devices on the same interface, you can actually split them into groups and assign each group a different guaranteed bandwidth. You do it using a traffic shaping on the interface itself. Let's see how. To create a traffic shaping on an interface, you will need to create address objects for the different objects or devices on your interface that you wish to guarantee specific bandwidth. So in our case, let's look at finance, which is at the 10.0.7.0 subnet. Now, I've already created 2 address objects. Let's just look at them. Those are PC1 and PC2. One is at the 10.0.7.11 and the second is at the 10.0.7.22. My aim is to give PC1 10% of the bandwidth and PC2 90%. You can of course change it per your needs. So the very first thing that you will need to do is to create a traffic shaping policy. Let's create a new one. Now we'll create a traffic shaping for PC1. The source is PC1. Destination is all. Service is all. You can of course change it to each service that you wish to apply those limits. Now in the action you assign shaping class ID. The outgoing interface is our WAN interface And in the traffic shaping class ID, you can actually assign different class IDs. Just press the create. Now you have up to 31 class IDs. Let's choose class number 10. No, 10 is already taken. So let's choose class ID number 5. Let's name it 5 also. All right. So we'll assign it class ID of 5. Okay. Let's create another shaping policy for PC2. Source is PC2. Destination is all. Service all. Assigned shaping class ID. The outgoing interface is our WAN interface. And let's create another class ID number 6. Okay, now let's apply that. So we have two traffic shaping policies. Now let's move to traffic shaping profile. In shaping profile, we actually define the profile that we will enable on the interface later. So the profile is finest. Let's name it finest. And let's create new profile. Now the first class ID is 5, that belongs to PC1. The guaranteed bandwidth is 10% of the total bandwidth. The maximum is also 10%. Let's give them both priority of high. Okay. All right, so let's just choose class ID of 6, guaranteed bandwidth 90%, and priority high. Okay, now we have a new profile, which is the finance profile. We have two class IDs with different guaranteed and maximum bandwidth. You can also see the illustration here. Okay, the last thing that you will need to do is to move back to your network interface, finance. Let's edit this one. And on the traffic shaping, let's just enable outbound shaping profile. The shaping profile that we have just created is finance. Now you will need to specify your interface bandwidth. So in my case, it's 100 megabits. And there we have it. Did you know that your Fortigate has a built-in iPerf client you can use against public iPerf servers and test your bandwidth in a much more accurate way? In this following guide, we will look at how we do it, how we configure the different parameters such as the amount of TCP streams, protocol used, either UDP or TCP, coming up. Alright, so now let's use the iPerf client. Now your Fortigate has an iPerf client, as said. It also has an embedded iPerf server. So let's start by checking throughput between two interfaces. To do so, you'll use the Diag traffic test, client interface, and the first is our port 1, which is, no, let's use port 2, which is our marketing division. The second thing that we will do is Diag traffic test, server interface, that will be our WAN interface. So let's use port 1. And if we'll use the Diag traffic test show, we will also see the current configuration. Now to run the test, we will use Diag traffic test run. And there we have it. Now, it's not that interesting to look at the bandwidth or the throughput between two interfaces. We want to check our Fortigate against a public iPerf server. Now, there are dozens of public free iPerf servers that you can find on the internet. Fortinet doesn't allow you to enter the URL. You will have to enter the IP address. Now, to start that, we will use Diag traffic test. Let's use our client, which is at port 1. That's our WAN interface. Now, the next thing you can also do is to use different protocols. Now, if you use Proto 0, that is TCP. If you're using Protocol 1, that is UDP. So if you have voice over IP devices on your network, do the test over UDP also, but for now we will use Proto 0, which is TCP. Another thing that you can do, if you use the Diag traffic test run -h, you will see the different parameters that you can tweak, that you can play around. One of them is the -p. The -p actually allows you to send parallel connections, parallel streams to the server itself. It is much more accurate than one TCP connection. So use it, use 6, 10 streams towards that server. It will give you a much more accurate result. All right, now let's just move back. Now let's just use the Diag traffic test. Let's run it. Let's run it against our server, which is a public server that is at 89.84.1.222. Now we have forgotten to do one more thing, that is using the port number. The port that it uses is 5209. The default port for iPerfs is 5201, but this one uses also 5209. So let's just use that port, and let's use Diag traffic test run -c, and the address is 89.84.1.222. Your IPS engine is probably one of the most valuable resources of your Fortigate firewall. Now, it has different database signatures for data rate signatures, for anomalies, for exploits, and most of us just pick signatures of high priority and apply them to the policy itself. Now, there are several commands, command line commands, that you need to know to fine-tune your IPS and understand whenever there is an issue with the IPS, such as CPU spikes, or maybe your Fortigate gets into a conserve mode, you will need to analyze the issue. Optimizing your IPS engine, coming up. If you're having issues with your IPS engine in terms of CPU spikes, CPU utilization, the very first thing that you will need to do is to use the Diag test application IPS monitor. Now press the question mark and enter. You will see a list of options that you can choose from. The most important ones, in my opinion, is the option number 5, toggle bypass status. So let's just use number 5. When you do so, you actually enable bypass or disable bypass. That is, if you're still having an issue with your CPU after enabling the bypass, that is, your IPS will still work, but it will not inspect traffic, then you're probably having an issue with a network congestion, or your Fortigate is not up to the task. There's too much traffic. But if you're disabling bypass, that is, your IPS still works and inspects traffic, and you're still having issues with the CPU, that means that you probably have an issue with your IPS engine. Now you can turn or disable your IPS. You can do it using option 2. And if you want to start your IPS engine again, you can use option 99. That will actually restart all your IPS engine's operations. So you can do that, and it actually restarts all your IPS operations. The second command to optimize your IPS operations is done in the global configuration of your IPS. So use the config IPS global. Now, if you press the show full configuration, you will see a list of options. You can choose the database, either regular or extended. You can choose the size of the buffer itself, the socket size. It depends on your Fortigate model. If you are using a Fortigate with several CPUs, you can actually even choose the number of IPS engine. But one of the most important options that you can play around is the intelligent mode. Currently, it is by default enabled. The intelligent mode actually means that your Fortigate IPS engine will look at the session itself. It will not scan by default every byte in this session. It will look and it will use heuristics and other techniques to choose if to scan the whole session or to stop scanning the traffic, the session traffic, upon recognizing that it is secure enough. So be sure that you're using the intelligent mode that will actually offload CPU resources, memory resources from your Fortigate. There are times when we need to customize our own IPS and application signatures. The quick guide to creating your own signatures is coming up. Don't go anywhere. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. When we speak of the intrusion prevention systems, we speak of an engine that compares traffic against signatures. Signatures of known threats and anomalies. Now, whenever the IPS engine alerts us, it's in our responsibility to either block, monitor, or allow the traffic. Signatures allows us to identify malicious attacks, and the question that arises is, why do we need to create our own customized signatures? Fortinet has already provided us with thousands of signatures. There are two main reasons. The first one, sometimes we use a specific application, we use our own set of tools or our own topology that is customized to our need, and we need to create a customized signatures that will match. And the second reason is for threats that somehow doesn't have any signatures yet. So how do we create one? Let's head over to our IPS sensor page, signatures view, and then create new. The following signature is probably the most basic one. If you want more advanced signatures, please leave a comment in the comments page. Our first signature will allow us to block the CNN.com website. There are dozens of ways using web filter application controls to do it, but we are here to learn how we customize our own signature, and that's a good start. Now, every signature starts with a header. The header for every signature starts with F, SBID, that's the header text, and then we open parentheses. In the parentheses within them, we enter the signature matching criteria. Criteria of that signatures are described using a keyword and a value. And different keywords, if you're using a different keywords, you can use only one keyword and a value. You will divide different or separate different keywords using a semicolon. The first keyword is usually the name of the signature. We have to give our signature a clear description of the attack, and then we define the signature triggering. What makes it active in the attack? Which type of protocols are we looking into? The flow of packets, the amount of packet. We are looking for matches in the traffic itself. We match based on specific headers, specific patterns, thresholds, as in rate-based engines. For that, we use keywords. Two types of keyword example is service and protocol. Now, in service, we determine, as in our case, that the service is HTTP, since we wish to block a website. In protocols, we can specify if we will use TCP, as most websites use, or maybe we plan to block our site not only to users that go through TCP in their browser, but also users that may connect to that website using different protocols such as FTP. Each keyword must start with a pair of dashes. Another keyword is flow, that is the flow of the traffic. Does it come from the server towards a client, or from clients towards a server? Or maybe it is bidirectional. In our case, we wish to block any users that are clients from going to a web server that is the CNN.com web server. And there are many more parameters and patterns that we can add, but this is the basic syntax that we use to customize our signature. So let's try one right now. Let's name our IPS signature. Let's add some comments. So we will start with the F-S bid, and we will open the parenthesis. Now let's choose a name for the custom signature, and our name will be blockcnn.com. The next thing to do is to add a pattern. We will use a regular expression pattern that is cnn.com, and now our FortiGate will detect the URL, and as we add up the service, which is HTTP, it will know that it will only look up for that specific signature over HTTP protocol. Make note that we divide the different keywords with a semicolon. And now we will set up the protocol, which is actually the traffic type. FortiGate will only detect this signature in a TCP traffic. That is, if we will send a mail to that URL which runs over SMTP, or if we will connect to that URL over FTP, it will not do anything. It will only block the website over HTTP traffic. By default, patterns are case sensitive. So if we wish that FortiGate will block any attempt to get into that URL using uppercase or lowercase, we will use the no underscore case. And now let's limit the scanning only to traffic that is sent from the client. We can also use bidirectional, but in our case we will use the flow from client. And the last thing to do is to add up the context host, which makes the domain name to appear in the host field as it being resolved by the DNS. So that was our basic signature. Now, if you wish that we will create a more detailed, a more complicated signatures, just leave a comment in the comments page and I will do so. In this video, we are going to show you the top 5 IPS commands for your Fortigate, and we are starting right now. The inclusion of IPS in your Fortigate is one of those things that makes your Fortigate a next generation firewall. It deals with exploits, it deals with anomalies. IPS engine is just about everywhere. So let's start with our first command, that is config IPS global. There are some Fortigate models that supports also the extended database, which includes much more signature. So to check it out, set database, and you can use the regular, and you can also use the extended. So if you have the extended, don't hesitate to use it. When we create or configure IPS sensors, we need to plan them carefully. Why? Because they consume a lot of resources from your Fortigate in terms of CPU and memory. Now, whenever you head up to your IPS signatures page and add signatures, think of two main things. The first one, operating systems. If you're using a Windows-based network, don't use any signatures that are related to macOS or Linux. The second thing is the direction of the traffic. Now, if you're protecting clients, use only signatures that are meant to protect clients. If you're protecting server, do the same. The next command is for those who runs a Fortigate with multiple processors. You can actually run several IPS engines simultaneously. So how do you do it? You head over to your CLI, configure IPS global. Now set engine count. Now if you set the integer into 0, then Fortigate will choose how many engines to use simultaneously. But you can also change it according to your needs. Your IPS engine needs as much power as it can get. There are many Fortigate models that supports hardware acceleration, either using the NP ASIC or the CP ASIC. Mine uses the CP ASIC. So why not giving it to him? Use the config IPS global and then set, in my case it's the CP, set CP acceleration mode. Those that supports the NP, just use the set NP acceleration mode and set it to basic or to none, or in this CP case to an advanced mode which supports more IPS patterns. Your IPS engine consumes lots and lots of memory and CPU cycles. Now, if you see spikes in your Fortigate due to CPU high usage and so on, you can diagnose, test application, IPS monitor, and there you will see different tests that you can do on your IPS engine. You can disable it totally using option 2, or you can toggle bypass status, which actually means that the IPS engine works but doesn't scan any traffic. So play around with those options whenever you have issues with your IPS engine. And before we end, please subscribe to get more videos like that. Two features that you must enable on your IPsec tunnel. to make it more secure and more reliable. Coming up. Your IPsec tunnel is actually comprised of two phases. Those are phase 1 and phase 2. In phase 1, IKE is the protocol that is being used and manages the connection itself, the tunnel itself. It is also responsible for the SA. Those are the security association, the cipher algorithms, and the hash functions that are actually being negotiated between the two peers. Now, in phase 1, which is the initial phase, you will see a forward error correction feature that you can enable or disable. Why do you need to enable it? Well, since that feature adds additional packets with redundant data. So if for any reason your connection suffers from congestion and you're seeing packet loss, forward error correction will help you to reconstruct any packet, any lost packet or error that you will see in the transmission. Now, it will add up to the time that it takes to build up the tunnel itself, but your tunnel will be much more reliable for the long term. The second feature that will make your IPsec much more secure is the perfect forwarding secrecy. Now, you will see it only in phase 2. The thing is that in phase 2, your IPsec tunnel will actually extract new keying material from the Diffie-Hellman key exchange. Now, we will not get into the Diffie-Hellman algorithm and how that works. I will just say that it is being used to share or to create a shared secret key between the two parties, between the two VPN gateways. Now, if you're not enabling perfect forwarding secrecy, the Diffie-Hellman that is done at phase 2 will actually extract new keying material from the initial phase 1 Diffie-Hellman key exchange. If you enable perfect forwarding secrecy, there's a new key exchange that is being performed. The keys that are actually being generated are not dependent on the first phase. So this will make your process a bit more slower, but it will make your IPsec tunnel much more secure as you are using a new session keys that cannot be compromised nor derived from the initial phase. If you're using one of the latest firmwares on your Fortigate, then you have probably seen that on an interface you can configure receive LLDP and transmit LLDP. Now, what is an LLDP? An LLDP is actually a link layer discovery protocol used by most network devices to advertise their capabilities, their identity. Who are the neighbors? Who are they connected to? Now, we have seen link layer discovery protocol before. Cisco has one which is proprietary, that is the CDP. But now you can use LLDP to know which devices are connected to your Fortigate. So let's enable device identification and let's see how LLDP shows up in Wireshark. Coming up. A receiving LLDP device actually stores the data that it got from its neighbor on a database. Now, that database can be accessed using SMP. If we want to use LLDP, we have to turn on device identification and we have to turn on LLDP receive and transmit per interface or on a global basis. We will do it per interface. So let's move to the command line. Now we can also do it using the graphical user interface, but we will do it on the command line. All right, so let's just clear the screen, config system interface. Now The interface we're dealing with is port 2. So let's edit port 2. All right, now let's set device identification to enable. Let's set LLDP reception to enable. And let's set LLDP transmission also to enable. Let's just get out of it and let's refresh our page. And there we have it. We have receive LLDP enabled and transmit LLDP enabled. And if we scroll down, we can see that we also have device detection. Now let's capture the traffic using Wireshark and let's see what happens. Let's open up Wireshark. Let's capture the traffic. If you'll do so using your home network devices, you will probably see that your smart TV uses LLDP to find out nearby devices. LLDP is used just about everywhere. Let's stop our capture and now let's filter LLDP. Alright, let's just double click on the frame itself. Let's open up all the different headers so we can actually see that we're having the marketing. Remember, the marketing interface is the interface that is supporting either receiving and transmitting LLDP information. We can also see our device name, which is our Fortigate. It is a virtual machine. That's the build type. You can find tons of information on each device that is sending LLDP frames towards other devices on your network. On your internal LAN, you have 3 web servers that serves the same data. Now, when a client asks for that data using HTTP GET, you can actually load balance the request between the 3 web servers. How do you do it? You're using a load balancing virtual server. You can load balance the traffic based on different protocols, either HTTP or HTTPS. And you can use different load balancing algorithms such as weighted, round robin, or even one that has the least round trip time. So let's do it. Creating a load balancing virtual server is quite similar to creating a virtual IP, but this time we're creating a virtual server with different load balancing algorithm and from different types. So the first thing to do is to head over to System, Feature Visibility, Load Balance, and Apply. Once you do so, you will see that in Policy and Objects you have a new Virtual Servers menu. Let's just create one. Let's name our new virtual server web server. The type will be HTTP, but you can also use HTTPS and other protocols. The interface is our WAN one. Now, although it is virtual, it has to have an IP that you got from your ISP. The virtual server IP, let's just make that one 82.0.2.1. Remember, an IP address that you got from your ISP. The virtual server port will be 8080. The load balancing method, now you can use different algorithms. If you want to treat the web servers equally, then just use round robin, but you can also use weighted. If you will use weighted, you will see that when you create a real server, you can actually add weight to the different servers, but we'll use round robin. Now, persistence, it's a good practice to use a cookie. If you're using e-commerce, do so. Let's just do so. And you can also actually create a health check. The same way as you create a health check monitor to check different servers for route failure, you can create a health check that will ping the different servers and get their round trip time and more parameters. But we are not using health check. Now, the next thing to do is to actually map the virtual server to our real server. So let's just create a new server. Now that's the IP address of our servers in our LAN interface. So let's just use the 10.0.4.1. Port will be port 80, and when you're using maximum connections equal to 0, that is limitless connections. The mode should be active. Okay, now let's create another web server that will be at the 10.0.4.7. Again, port 80, maximum connection 0, and active mode. Alright, so we have two servers, two real servers, one virtual server that our clients will actually connect to from the outside, from the internet. And the next thing to do is to actually create a policy that will allow users to connect to our web servers. So we'll create new, let's name our policy. The policy name will be web server balance. Now the incoming interface is our WAN interface. The outgoing interface is our web server LAN interface. The source can be all. Now the destination, you need to move the inspection mode to proxy, and from there just choose destination as our web server. Now it won't work if you will do it using the flow-based inspection mode. Scheduling always, service all. Make sure that you are using net mode and dynamic IP pool. Now you can use any security profile over it, and that's about it. Up until now, in our different configurations, we have configured Google's DNS server as our main DNS server. We also configured DHCP services to run on just about any interface of our Fortigate. But if we need a local DNS server that will serve different hosts in our LAN and will be private only to the LAN users, we can do it using DNS databases. Coming up. So currently I'm using Google's DNS server as my primary DNS server, and as my secondary I'm using the FortiGuard DNS server. Now if I want to create a local DNS server that will hold records of different hosts on my local area network, such as my web server or my NAS, I will need to head over to System, Feature Visibility, Enable DNS Database. Alright, and now in network you will have a new menu which is DNS server. Now we will start with the DNS database. We will create the zone itself. The type is master, since our DNS server will be the master DNS server. The view will be shadow. It will not be public to other users beside my LAN. So only users in my LAN can actually use and see the DNS server. Let's name the DNS zone. Let's just name it my company. And the domain name will be fortitip.com. The host name of our DNS server will be DNS. Let's just leave aside the email address. The other settings, the time to live is currently 24 ours. Let's leave it that way. And we will disable the authoritative since we don't want our DNS server to be authoritative. We only want to be recursive. That is, in the case that it doesn't have the right answer or it doesn't have the answer, it will actually send it towards another DNS server. Now let's create the DNS entries. So let's create a record, which is actually the IP address behind a host. Let's name our host web server, and the IP address of our host, just for our demo purposes, is 10.0.3.88. Okay. Now, the other thing to do is to actually apply it to the interface itself. So let's just apply it to the interface, and let's make the mode to a recursive mode. Now we have configured only one A record to our web server, but you can add up as many as you wish.